hero and we have our representation of our ground plane. We want to prototype some basic camera and character controls. This should sound a little bit familiar to what we did last term. Last term we dug down and we developed our own from scratch. We're going to take a little different approach here because we're going to try and copy Mario 64 a little more closely. Okay, what do we start with? Camera or character? Let's start with character. So here's our hero. If we want to make our hero move under keyboard control, what are we going to have to do? We're going to need a script. We're going to need some kind of component. So let's right click, we'll go create C# script. We'll call it hero control, CTRL. And if we want our hero game object to run that script, how do we associate it? Drag and drop. Or click add component. And we can type in hero and it will auto complete by the name that you type, and you just have to hit enter. Either way is fine. Let's work on that script. So I'm going to double click it and my text editor will open. I'm going to have Mono develop open because I love Mono. I know some of you may be using Visual Studio. That's fine too. So here's my text editor. I'm going to leave a little comment at the top. This class puts the hero of the game under user input control. Something like that. What are we going to need? If we're fetching user input control, what's one thing we probably will need?
Some sort of listener for set control?
Yeah, something where we can get the input. And you guys probably have Xbox USB controllers. If you don't, you may have a PS3 or a PS4 controller, or maybe you have a keyboard on your laptop, and maybe you have some kind of device that has axes. A keyboard will be fine. I'm going to use a public vector 3, and I'm going to call this inputs. Just because I want to see in the editor what values I am getting from whatever input device so that I can debug my code while it's running. All right. Every frame we're going to do something, which means we're going to need a hero control update method. And we're going to get the input every frame. The x value of our input vector that we're using for caching our values is going to be whatever is like the x-axis. Where does that come from? Get axis. And you may remember there are two axes that come predefined when you make a fresh project in Unity. We can add other axes if we want to use the right analog stick for camera, or if you have a leap motion, you can do an arbitrary number of axes. What axis is kind of this stuff in this way?
Horizontal.
This direction. Yeah, let's try horizontal. And we're also going to make that a lowercase I, because we're not talking about the names, the static class inputs. We're going to say the vertical is going to be stored in, let's say Z. If we do that, and we run our game, we'll switch back to here. Right off the bat, if we set focus on our hero, we've got our inputs vector there. And if I use the keyboard, you'll see in the right-hand side in the inspector, I can, my X and my Z are moving sensibly. So that's nice. All right. So if we push up on the joystick, we push up on the analog stick, what does Mario typically do? He walks forward. If we push back on it, he either backs up slowly or turns around and faces the other way, depending on the context. Okay? So we're going to say the vertical axis corresponds to forward or back movement, right? How can we actually move our joystick? How can we actually move our character based off of this value here? We've got a value that ranges from -1 to 1.
Transform dot position.
We could set the transport dot position directly, and that would overwrite the position by new position. And we've added in a little bit. We could go and we could add it ourselves.
Or you could increment the position.
I'm going to use, that's right, I'm going to use transform dot translate, which is a method built in, which will do the adding for us. Using transform dot translate is a little bit safer than transform dot position plus equals, because this interfaces a little bit better with the rigid body system. And if we end up adding a capsule collider, sorry, we do have a capsule collider. If we end up adding a rigid body or having any scenarios where we need to do some forces stuff with him, it's going to be less jittery in fixed update. So let's use transform dot translate. It takes a vector 3, moves the transform in the direction and distance of translation. Well, what's the direction that we want to translate our character in? We always want him to walk forward. And what way does he always face in terms of his transform? My x is this way, my y is this way, my z is this way. This is my x. If I walk this way, I'm facing this way.
Oh, you're saying as the Mario? No, as the Mario, you
As
want
the
the
Mario.
Z. You want the Z for
Correct. We're doing hero control. Then we'll do camera control.
Yeah, for the so Mario would be Z.
Okay. So we're going to take input dot z times this dot transform dot forward. Take the forward vector out of our transform and scale it by the value out of our joystick. If the joystick's not moving, we're not moving. If it's moving full on, we're moving at 1.0 times the forward vector. Maybe that's not the right speed for our game. Maybe we'll have to add in some more code to fix that, but it'll get us a first feeling for moving forward and back.
You got a capital I.
Very good. Boom. So, small changes, test often. Let's flip back to the editor and test again what this does. Okay, I'm going to pivot around just a little bit to look at him from that point of view. If I click back on my thing and I push forward, he walks forward. If I push back, he walks back. If I take my hero and I click on him, how can I test that this is actually working in a few more cases? If I rotate him 45 degrees manually, and then I press forward on my joystick, what do you think? Is it correct?
You're only holding down one key or two? Or you
I'm pushing straight up, straight down. Is he walking straight forward and straight back?
diagonal.
He's walking diagonally. If I push 90 degrees, if I rotate him 90 degrees from the beginning, and we go forward and back, what's actually happening here?
Whatever forward is supposed to be is not corresponding to forward position of capsule.
So what do we really want to be doing here? So what's the difference? How do we fix this? This dot transform dot forward doesn't seem to work. Right? We didn't like that, but
have to set.
vector 3 dot forward. Why is that different? If we look at what transform.translate does, Unity 3D transform.translate, there's actually two versions. One that takes a relative to and one that doesn't. If we don't give it the coordinates, the space that the vector is in, what does it assume?
Space else.
It assumes the space itself. It assumes local. Okay? But we're not actually translating it in local when we apply a rotation. We're translating it in global. So we could manually say space.world, or we could always specify the forward vector. In our local space, in our local coordinates, what is forward? It's always the z vector, 0, 0, 1. No matter which way I'm facing, if I'm sitting on my capsule and I ask myself, transform, what is your forward vector? It will always say 0, 0, 1 in local coordinates, because relative to me, 0, 0, 1 is always straight forward in front of me, regardless of which way I'm facing. And because the default is self, that's how it works. Because when we were using this dot transform dot forward, we were actually getting different vectors out of it. And so he was rotating too much. So coordinate system matters. Cool? All right. So let's add the rotation so that we don't have to actually manually rotate it in the editor. How can we make our capsule rotate under user control? What do we want to do?
I would assume if we, well, just holding one of them down makes you go straight forward in that direction, holding one of the forward or back at the same time as having the left or the right should be able to cause it to turn.
Yeah, we'll drive left and right by the horizontal axis. So this dot transform dot rotate. There's 6 forms of this function, okay, depending on what you want to give. I'm going to pick form number 3 that takes an axis and an angle. So I'm going to rotate about a certain axis by a certain angle. What vector, what axis are we rotating around if we're turning left and right? Yeah, y, the up vertical, right? The vertical axis. Left and right is always going to mean turn left and turn right. We're not doing a 3D flight sim where you can walk on the walls and turn left to right actually means like up and down or anything. We're always going to assume that you're grounded on the ground and like your head always faces up. Even in Mario Galaxy, that is true. They do a transformation into spherical coordinates, but up is always the way your head is when you're standing. We'll always assume that. So we're going to do rotate. And we're going to take vector 3 dot what? What's the up vector? Dot y? Dot up. And we're going to rotate it by, what's the speed that we want to rotate by? Yeah. And I'm actually going to scale that by, well, we'll see if we need to scale that. Go back here, press play again. I said press play again. Forward and back still works. Let's try left and right. There's your left, there's your right. And then forward and back. Is that forward and back's actually pretty fast?
Yeah.
The rotation's actually kind of slow for me. I don't know about you. So I think that's not bad. How can we make that better? I'm gonna add a rot speed so that we can scale how fast we turn left and right. We might wanna make that a little bit bigger, and we're gonna multiply our walking speed by walk speed so that we can slow that down a bit. And we're gonna give, once those publics show up again, we're gonna give rot speed something like 1.5, and we're gonna give the other one 0.75. Actually 0.6. Maybe that'll feel better. There's forward and back, there's left and right. That's not bad. So we added rot for rotation speed and walk for walking speed, and we're multiplying through when we do the translate by walk speed, and when we do the rotate, we're multiplying through by rotation speed. So far, so good. All right. All right. What's the next thing we need? If you said, let's do some camera controls, I would agree. What does the Mario 64 camera do? Yeah, it kind of goes behind him.
Yeah, so I guess not behind Mario itself, but then you can also turn it around using left and right C.
You can fiddle with it with some buttons, but the default behavior is it kind of
And you can zoom in or zoom out with it.
also has zoom in and out.
Remote in on Mario if you press the right trigger.
So there's some like helper functions, but the core behavior is kind of get behind him while he's walking.
Yeah.
Yeah, okay. So let's start with the core behavior and then we'll embellish on it.
Sweet.
All right. The easiest way, we're going to try something different. We're going to go to Assets, Import Package, and we're going to look at some of the examples that come with Unity 5.4. So there's a cameras package. I'm not going to use that. I'm actually going to use the characters package. Everything's in here. There's a lot of different assets. I'm going to import the whole thing. We're only going to use probably smooth follow. Actually, I'm going to say none, and I'm just going to import smooth follow. Okay? We're not going to keep any of this extra stuff. If we need it, maybe we'll go back and revisit it, but let's just do that. So I'll add one script. So in your standard assets, you're going to see under utility, smooth follow. We're going to tell the camera to smooth follow the player, okay? This will look very similar to last semester's camera code, and we will expand on this in the near future. It's a script that takes a transform and always wants to preserve a distance and a height from that transform behind it, and there's a couple parameters where you can tweak how fast it follows in the horizontal axis and how fast it follows in the vertical axis. That's what the last two numbers are. So I'm going to set that to 5 and 5. And I'm going to say the target you're going to follow is the hero. So a little drag and drop there. If I press play, the camera is following the character at this point. We know it's live because if we change the height from 5, we want to dial that up. We give it some non-zero values there. We can live control the height, and it's going to add up based off of the dampening value. It's going to track the object at different speeds, and we can adjust the distance. Putting the character under control now. As we rotate and let go, the camera goes behind him. We can turn. The camera's going to follow behind. So we've got something that's following our little dolly capsule at basically a constant speed, and it doesn't lose the guy.